Hello everyone, welcome back to my channel. In this video, we'll be talking about how to convert decimal numbers to binary. So in this tutorial, you'll be using powers of 2 a lot. So I have listed some powers of 2 ranging from -4 to 9. You can go ahead and list other powers of 2 whenever you encounter a problem which has a bigger value you can't find in this table. Let's jump into it. The first number we are going to convert to binary is 100. So in converting any number to binary, what you are supposed to do is to pick the decimal number and then compare it to the numbers in the table, which is 2, 4, 6, 8, 16, 32. That is the powers of 2. So when we compare 100 to the numbers in the table, we could see that we can't find 100 in the table, but the number just under 100 is 64. So we're going to write 64. And then we subtract 64 from 100. Subtracting 64 from 100, we get 36. So plus, we compare 36 to the values we have in the table. There is no 36, but the value just under 36 is 32. Plus 32. We add 32 to 64. And then we subtract 32 from 36. 32. When we subtract 32 from 36, the result is 4. When we compare 4 to the values in the table, we can find 4 in the table plus 4. After getting 4, you subtract 4 from 4 and you are getting 0. So over here, we sum up these values to confirm if they give us 100. 64 plus 32 is 96 plus 4 is 100. Now we compare 64, 32 and then 4 to the values in the table again. If you find 64 over here and you find 64 in the table, you represent it as 1. So 64, 64, you represent it as 1. 32 here, 32 in the table, that will be 1. 16 in the table, no 16 in the sum of numbers, so you represent it as 0. 8 in the table, no 8 in the sum of numbers, so that will be 0. 4 in the table and then 4 in the sum of numbers, so that will be 1. And then 2 in the table, no 2 in the sum of numbers, so 0. 1 in the table, no 1 in the sum of numbers, so that will be 0. So 100 in binary is 1100100. That's 100 in binary. Now let's move on to the second example. The second example is 117. Converting 117 to binary, as usual, you compare 117 to the values we have in the table. We do not have 117 in the table, but the value just under 117 is 64. So we write 64. And then we subtract 64 from 117. 64 from 117 is 53. Comparing 53 to the values in the table, we do not have 53, but the value just under 53 is 32. And then we subtract 32 from 53. 32 from 53 is 21. Comparing 21 to the values in the table, the value just under 21 is 16 plus 16. 16 from 21. 16 from 21 is 5. Comparing 5, the value just under 5 is 4. We subtract 4 from 5 and the result is 1. We have 1 in the table. So after you get this, you sum up the numbers and confirm if they gives 117. 64 plus 32 plus 16 plus 4 plus 1 is 117. After getting these values, we compare them to the table as usual. We have 16 in the sum of numbers, 16 in the table, we represent it as 1. We have 32 and then 32, we represent it as 1. We have 16, 16, that will be 1. 8 in the table, no 8 in the sum of numbers, that will be 0. 4 in the table, 4 in the sum of numbers, 1. 2 in the table and then no 2 in the sum of numbers, that will be 0. 1 in the table and then 1 in the sum of numbers, that will be 1. So 117 in binary is 1110101. That is 117 in binary. Now let's try a bigger value. A bigger value like 400. So in converting 400 to binary, the first step is to compare 400 to the values we have in the table as usual. Comparing this 400 to the table, we could see the value just under 400 is 256. 256. We subtract 256 from 400. 256 from 400 is 144. We compare 144 to the table. We do not have 144, but we have the value just under 144 is 128 plus 128. 144 from 128 from 144 is 16. 16. Comparing 16 to the table, we have 16 in the table. So plus 16. 16 minus 16 is 0. Let's sum up these numbers and confirm if they add up to 400. 256 plus 128 plus 16 sum up to 400. So the next step is to compare the values, the sum of numbers to the values we have in the table. We have 256 here and then 256 in the table. So that will be 1, 128, 128, 1, 64, no 64, 0, 32, no 32, 0. We have 16, 16, 1, 8, no 8, 0, 4, no 4, 0, 2, no 2, 0, 1, no 1, and then 0. So that is, so 400 in binary is 110 0 1 0 0 0 0. 2, no 2, so here is actually 0, not 2. Now let's convert 15 into binary. Converting 15 into binary, we compare 15 to the values we have in the table. We don't have 15, but the value just under 15 is 8. We write 8. And then we subtract 8 from 15. When we take 8 from 15, the result is 7. Comparing 7 to the table, we do not have 7, but the value under 7 is 4. Subtracting 4 from 7, the result is 3. We do not have 3 in the table, the value under 3 is 2 plus 2. Subtracting 2 from 3, 1. And then comparing 1, we have 1 in the table, so plus 1. 1 minus 1, 0. Let's sum up. 8 plus 4, 12, plus 2, 14, plus 1, 15. So 15 in binary is, we have 8 and then 8, so that will be 1, 4 and then 4 in the table, 1, 2, 2, 1. We have 1 and then 1, that will be 1. So 15 in binary is 1 1 1 1. But what if you are being asked to leave your answer in 7 bits? 15 in binary is 1111. We have 4 bits, 1 2 3 4, but you are being asked to leave your answer in 7 bits. What you are supposed to do is just to add number of zeros to the left hand side to add up to the required number of bits. So here 7 bits, 15 in 7 bits is actually 0001111, adding as many as zeros to the left hand side to achieve your result. For example, when we have 20 00020, the number of zeros added to the left hand side doesn't change anything. If you see value in this video, subscribe to my channel, hit the like button and leave us a comment. See you in my next tutorial.